Alright, this is my lab 2, my video of lab 2. Initially, I got the skeleton code from that was provided to us from Blackboard. The only thing that I customized myself is those numbers here. I added these. These weren't the numbers that are in the lab manual, so I changed these numbers to match the ones that are in the lab manual for array 1 and array 2. All these are still the same. My sorting algorithm, it starts here with the sort subroutine. A lot of the things that I've implemented in my algorithm, I got the hints from the instructions that are down here. So a lot of this is those first few lines in the sort subroutine come from the instructions and my understanding of the instructions and my understanding of how the algorithm is supposed to work. First, R6 represent array 1 or array 2. Array 1 or array 2s. So, but I cannot change that itself. I have to, it was moving to R6 and they were moving to R6, and depending on which one is being called, which one is being worked on at the time. So, but to work on it myself without changing the content of R6, I have to move it into another register. So that's what I did here. Move the content of R6 into R8. I have to decrement R8 every time and also R9 every time because I have to keep counter of them. R9, as the instruction says down here, R9 is loop counter, while I keep n-1 of R8 for the next kin, because the bubble to bubble sort is like going through the array the first time while comparing each two consecutive numbers together. If the first one is greater than the other, you have to swap them because we are sorting in ascending order. So that's basically what the algorithm does, what the sorting array does, what the bubble sort does as well. And then you go through each two consecutive numbers, you compare them, and then you switch them if they need to be switched, if they're not in ascending order. And the next time you go through the array, you go one less time because you've compared the first two numbers already. You go one less time, and the last time you go to the array, you only go one time. That's how the bubble sort works. So moving on with my code, I'm gonna step through each line. I already explained this. I had to create two loops. Loop 1 big loop, which is loop 1, and then one smaller loop. I move R6 into R7 because I will be changing the content of R6, but I still want R6 to have the same value, so that's the reason they're moved. Now, to compare the two numbers, I don't want to change the content of R7. Well, I could change them, but it wouldn't make sense if I have all the registers there to use. So I'll move the first number that I want to compare into R13. Move the second number into R14. I compare them. If the first number is greater than the second number, then I have to swap them. If they're not, I do not swap. So for now we have the values of R11 and R14 there. Because R11 is less than R14, I do not swap. So I just move on with my code, increase R7 because I want to move on to the next entries to compare them. But I have to compare R7 to R9 because of the loop counter. If it's not greater, I just move on. And this repeats itself every time. So I'm not gonna go through all the iteration. You can see that the swap subroutine is called now because if we go check, you'll see that R13 is greater than R14. So I have to swap them so that R14 is greater than R13. Yeah, and my swap subroutine is pretty simple. Take the first number, I move it into R11. Take the second number, move it into the first number, and then the first number, move it into the second number. Because the first number I saved it in R11, so now I can move it into the second number. And pretty straightforward. And then my code works. So I've explained the swap subroutine and the do not swap subroutine when each of them are called and all that. So I'm gonna run the code all the way. And it's in the return. If I run it again, if I go step through, it goes back into sort 2 because I've gone through sort 1 now. All of the first array is sorted now. Now it's the second array that needs to be sorted. For the second array, it'd be basically the same thing. It'll go 5 clicks. Go, and then when sorry, when I get to sort, I'm gonna step into it. You see that it just goes into sort and it starts. It does the initialization, initial decrements. And it goes into the loop. It'll do the same thing as before. If the numbers are equal or if they're greater, if 13 is greater than 14, I'll swap them. If they're not, I won't swap. And so I'm gonna run the whole code until it gets to okay, it gets to the main loop, which is the infinite loop, loops forever. I'm gonna go to memory browser and look at array1 sort. Okay, array1 sort is 0 to 10. So if I go 0 to 10, press, this should be array1 sort. It starts at B3. It's not, it doesn't start at 0A. It's that little Indian way of writing things for MSP 430. The smaller one is written first and then the higher one second. Yeah, but this is array1 starts at B3 and it believes it ends at 37 and 42 is not included, so 10 numbers: B3, F7, F9, 0808, 11, 16, 24, 25, and then 37. Array2S starts at 230, I believe, yes. I go to 230. This is array 2s. Array 2s starts at b6. b6, which represent negative 74. So negative 74, and by an hexadecimal number is b6. So array 2 sorted is b6, b8 d9, e9 f9, 0 0 0 e, 13 2c, and I believe it ends at 3c, right? 10 numbers. So it works. This one algorithm works. So that's all I got for you guys today. I'm not sure if I've explained everything correctly. The sorting algorithm work with the help of the instructions down here. The help of the TA, it worked out. Thank you. I don't want this video to be too long because these videos take too long to be uploaded. Thank you.